Hello, everyone. And myself and Nathan will be sort of running this in parallel. So it'd be a bit more of a conversation rather than just each of us presenting. So we may have the need to jump on top of each other from a conversation perspective if need be, and maybe go back and forth a little bit with the presentation slides. So I apologise in advance if that does occur. And Andrew's warned us as well that he may stick his head in at some point to add some content or correct us on any of our content. So Andrew may be popping in and out as required. So as Andrew said, today we'll be presenting about timber hotel design as well as construction, because in the industry, a lot of the time it's a D&C agreement and design must consider the construction elements. So I've got a fair bit of design experience, but mainly we'll be talking from a builder's perspective, and Nathan from an engineering side of things. Go to the next slide, Nathan. Myself and Nathan have worked on a number of different projects, and even though this is focused mainly on hotels, of which we both have experience in, I think it's also important to note that some of the design and construction components that need to be discussed and considered also link to other types of construction, and we can learn from some experiences that we've both had in developing designs for commercial offices as well as residential, and try to bring those philosophies across. What you can see on the screen there, more notably top left-hand corner, is 55 South, which both myself and Nathan worked on, and the other hotel is the Adelaide Oval Hotel, which I wasn't involved in, but Nathan was. But we will reference these throughout the presentation.
All right. Okay. Welcome, everyone. All right. Apologies to all the architects tuning in, because I'm sure you have much more eloquent terminology for this. But what I want to discuss is essentially pretty much the two basic typologies for a hotel that I term the block and then the linear type approach. So the block is something that will have a pretty low aspect ratio, lots of inherent stability. And then the linear is obviously a lot longer, possibly taller, and more of a slender approach. And then I've obviously added in extensions as well, because that's really relevant at the moment. And there's lots of opportunities by using timber that can really help unlock those extension approaches due to the high strength to weight ratio of timber, and therefore the reduction of the impact on the existing building stock below. So with these types of approaches, with a block building, like I said, lots more inherent stability. Generally, you'll have more of a honeycomb type structure, so lots of shear walls in multiple directions. Subject to the height, of course, you may very well be able to use like a pure timber approach, whether that be light timber framing or mass timber, such as CLT, with lots of shear walls and things to transfer your lateral loads down to the foundations. Whereas a linear approach, you're more likely to have to rely on cores that are likely concrete or steel, and you're going to also have to have a much stronger and stiffer diaphragm in that sort of an approach.
Yeah, and with that, from a buildability perspective, and we'll talk about this in more detail later on in the presentation, is the need for hybrid design and construction approaches. So it's really great, but not enormously common to have a pure timber building like the block formation that Nathan shows on the screen here, where you can have a timber core and the ability to manage those connections, manage all the materials and the interfaces, albeit timber, the differential settlement components of everything being very consistent. However, if you're looking at a hybrid solution where you're needing steel or concrete, you really need to spend a lot of time and focus on the D&C components that link at those interfaces and how the different types of structures react and connect to each other.
Yeah, a lot more coordination required on that front. Yeah, so I think for hotel buildings, they really lend themselves to something that has a direct load path more often than not. Generally, from an architectural perspective and an end user requirement anyway, you're not going to want a hotel to have various layouts floor to floor. It just doesn't make a lot of sense from a logistics and service perspective. But if it is possible to have transfer, and we've certainly achieved that on some projects, not a hotel, at an apartment building recently. But I just wanted to point out that it's the best approach from a structural engineering perspective on any building, but particularly with these buildings, is to have a direct load path. It means that you don't have costly transfer structure. You're also reducing the risk of progressive collapse and things like that, as well as it really makes your service reticulation a lot easier. Having bathrooms aligning, you can have service risers run from the top down to the bottom or to your transfer level.
And from a cost perspective too, trying to implement transfers in any type of structure, it's challenging from a cost side of things, so it does increase the cost of the build. And from a buildability perspective, having every level repetitive is much easier to manage from a buildability side of things as well.
Yeah, for sure. Just some examples. I'm sure everyone, well, lots of you are aware of 55 South Bank. So this is more of a honeycomb type approach, but also obviously an extension. Adelaide Oval Hotel, as Rob mentioned earlier, this is more of a linear type approach, but it is also laterally tied back to the oval structure itself. So it's a little bit hotel over in the States, a Lend-Lease project. These images sort of imply that it is more linear, but due to it only being 4 stories, there's a bit of depth to it. And I'm pretty sure this was a pure CLT project above the slab on ground and the foundations. So there's just another use. And looking at the facade, I mean, you wouldn't know that it's a CLT building at all. It looks like a very traditional style project. Same with Adelaide Oval Hotel. They were my photos. I actually got to go through there over the holidays, and being in that building, I'm sure none of the patrons know that they're in a CLT building whatsoever.
Yeah. And the same goes for South Bank. It's all fully encapsulated. And just another comment on this. I wasn't involved in this project. Really only seeing the image now. But I know in the US they do operate a lot of timber frame structures, especially at that height. So there's no reason why a timber frame solution could be adopted on a type of hotel or even residential style development of that scale, and having to deal with the other components that go with the design and construction of that. Yeah,
I don't want to speculate too much, but I believe Lend-Lease were doing lots of testing with CLT probably at the same time over in the US with the army and everything. So maybe that's why they were just doing some tests with CLT. But you're right, Rob, this could easily be a light timber frame approach for sure.
Yeah.
And then Brock Commons. So this is something that's a bit different. Rather than a panelised type structure, which hotels tend to lend themselves to due to the relatively short spans between party walls and things, this is a really clever approach that really opens up a lot of construction opportunities by freeing up and opening up the floor plan, and it speeds up the construction, getting to lock up much quicker, erecting that structure. So that's
yeah. So just spend a bit of time, I say a bit of time, but a few more seconds, just really observing this image, because we do bring this up on a number of occasions during the presentation. And the important things to note are that, how it's going away from that shear wall or honeycomb style structure. You're mainly dealing with posts, and this is more of a flat plate, no beam approach. The other thing to note too is the loading bins at each level at only one bay location. So just note those, and we'll reference that a bit further in what the challenges are with a traditional, more honeycomb style structure from a buildability and logistics perspective. Which leads us to the next bit, site access and cranage. So look, even though this is not a design component that needs to be considered during the design, say it's not a direct design relationship on a project, but understanding the site logistics and access is something that needs to be considered very, very early. In all my experiences working with the suppliers, a lot of the time jobs would progress to a certain level. We've got an example of this, and then it would get to buildability and realise that, hang on, we can't really get a truck in front of the site. It's very difficult to lift because all of these methodologies are very crane driven. So what you can see there on the left is 55 South Bank, the first day of lifting above the 2-level steel transfer. We had 10 levels of CLT above. And the top right-hand corner is the loading bay at 55 South Bank, which is If you look at the left image, it's to the right-hand side of that building next to where you can see the alley-mac or lift, workers' lift, protruding out of the trees there. So we were able to have one loading bay, which allowed one truck, and we were only able to have one crane allocated to the site. And I'll talk about that a bit later, about when the facade went in and what the methodology was. But if there's any opportunity to get more than one crane on these sites, or supplementary cranes with a tower and mobile, you really need to start capitalising on that, because it is very crane intensive. The other image is a stick wall or prefab wall frame with CLT floors. And one thing to note here is that generally with the wall frames, you would have to, or you could lift the packs up onto the live deck and then stand them up manually, rather than having a crane picking up every panel individually or in groups like you can see at South Bank. And then you need a crane to come in to drop the CLT floor in, albeit a floor cassette. We did one in Melbourne for former Australand. We used a tech beam floor cassette, and craneage was needed to lift each of those individual floor cassettes in. And my point here is that that works very well when you can have mobile cranes, because for a large section of each floor cycle, you don't need craneage to lift all the wall frames up. So if you've got a lot of downtime and your crane doesn't need to work, generally you want to be supplementing with mobile cranes.
Yeah, I'll just go back to your point earlier. Like, I totally agree. It's not something traditionally done by the engineer early in the design, but I really think it needs to be, with the whole sequencing and panelisation of these. More often than not, it's left totally up to the supplier to bring that in, but it does have significant design impacts, and I think it's important for engineers to be involved in those conversations and it to be part of their scope of works, because we know how much we worked on 55 South Bank, for example, with the sequencing and everything, and I think it adds a lot of value.
Definitely, mate. Yeah. So this next slide is a job that was built in Brunswick in Melbourne, and very, very difficult site access. And you can see the street parking, the overhead cables, and what we actually had to do was leave part of the concrete structure out to install or bring the mobile crane into that location. So what you can see on the left-hand side is where the crane is lifting CLT panels in, and the structure actually continues after we erect most of the CLT there. You then have to come back, do part of the concrete structure, and then erect the smaller components that we can do from the street with closures. So it's an example where, really it was a very difficult logistic project, but we were able to do it, but it did affect the design and some of the detailing that Nathan had to work on from a timber and concrete perspective.
Yeah, and like, we didn't do the concrete on this job, we were brought in late, but this just highlights, even from a traditional or conventional structural approach, just that need to look at a project holistically and think about these things early on, and actually think about construction loading. Like, that's something that's generally really separated. It goes to the builder, and then the builder has to engage a temps work engineer and things like this. But on this project, I believe they had to backprop the slab quite significantly for this crane and these sorts of things. It might be cost effective in some applications to actually just reinforce these elements to be able to take these construction loads.
So the next topic is structure and fit out. So, and more talking about sequencing. So this, Nathan showed an image, it was more of an aerial image of 55 South Bank, and this is a shot before the floor's installed and after the floor's installed of a typical unit and or a corridor on the right-hand side. And because we've got a honeycomb structure and pretty much all the walls are structural, what you end up having is this very difficult floor space to maneuver around, and trying to maneuver materials through all those doorways has led us to the need to actually preload packed materials per room with the crane on critical path. In addition to that, we were running bathroom pods. So it's something that needs to be considered. And when I referred back to the Brock Commons image, you couldn't run with those loading bins at one location every floor. You would have to pull the materials in from there and then maneuver them in the corridor through the door, and you'd have to manage that very, very difficultly. So we work with Vistek on this image, and it shows the amount of planning that went into propping locations and all the different materials with that colour-coded legend that needed to be incorporated and loaded in during the structure. So if you want to explain that in a bit more detail, Nath?
Yeah, well, I think it's just probably for all the engineers attending today, like it's not a very common thing that you'll have to do. Like, sure, I'm sure some have doing some temp engineering, but actually setting out the props and locating, and this was also done in 3D, by the way, and lots of meetings around sequencing and loading all of these material packs and the propping of the panels and things. But setting that out so that it could actually be the rooms be fit out at some point, and you could actually still maneuver around those packs to, fix the walls and do all the structural connections and everything. For these types of structures where you do have panelized systems such as CLT that really create those compartments, it's very important to go through this level of detail, I guess, for coordination more than anything.
Yeah, and just before we jump to the next slide, Nath, you also need to consider the need for cladding all of this material. So we've had to run a lot of plasterboard, load a lot of plasterboard in. And when we talk about costing of this type of structure, you need to also consider potentially spanning across 2 floors and then leaving a potential wall out. And whether that works structurally, whether you have the depths to span that far, that all needs to be analysed. But to be able to do that opens up the floor plate significantly. Also looking at potentially leaving corridor doors out. It just opens up the possibility of filling those in with lightweight walls and giving you accessibility around the entire structure for materials handling, and be able to focus the critical path purely on structure rather than having the load materials on, which is really challenging.
Yeah, we'll certainly quite often look at that option, every second wall being load bearing for different arrangements, particularly for hotels. And it's something that probably needs a bit more thought early on, just in terms of the cost and implications of that, because it's very easy to overlook the benefits on site, I guess, when you've got 2 costs and the material cost is more significant when you're not just loading every party wall.
Yeah, and just, look, I don't want to hang around too long on this slide because we want to keep to the time frame, but when we talk about costing of the hotel versus a apartment block, this is a very important point, because every wall on both solutions is a fire-rated, acoustic-rated wall, where if this was an apartment, you would not have an apartment the size of a hotel room. Your apartment would spread over at least 2 of these walls, if not 3. And then when you look at the concrete solution of a 9x9 grid, most of those internal walls are non-load bearing, just put in stud work with 10mm plasterboard, and that's it. And when you're comparing that to a timber structure and having to put load bearing elements in place of those internal apartment buildings, the cost starts really escalating, because you're comparing a 10mm plasterboard wall, non-load bearing, to a load bearing, fire rated mass timber wall or even lightweight wall.
Yeah,
so
with an additional acoustic wall.
Yeah, totally. And this is where the hotels tend to be a lot more cost effective with these types of solutions. When you compare, not to say apartments can't be, but just when you compare them, there's an advantage there when you look at these hotel rooms. And it leads on to this point. So this is a commercial office. It's one of Lend-Lease's jobs. They've built quite a few. They look fantastic, really innovative, a lot of exposed timber. But it's the whole discussion we wanted to just send out really today, is to start looking at a potential solution that is a post and prop commons, to incorporate that into these types of buildings like a hotel, which allows the loading to be completely free on the active deck or the decks below with no propping. So it's bringing a concrete construction methodology into the mix, but using timber and with all the benefits. And if you can achieve this, there's a lot of restrictions though with engineering and architecture that Nathan will talk about, but it will really allow you to focus on building that structure up on critical path, and as well as the facade, without dealing with that materials handling during the critical path elements.
Yeah, so with the post and beam type approach, I guess a limitation that I see is obviously you're going to have quite deep beams, which for a hotel building, typically you have a floor-to-floor height of, in the order of 3 meters, 3.2 sort of thing. So having such a deep structural element, that would need to be coordinated architecturally to align with the wall. It might be every third party wall, for example, or every second or something, so that can be built into the wall line ultimately. And then services, obviously, you can see here on the left that they've got a shorter grid span to allow the services to run underneath a shallower beam. But for a hotel style building, maybe you're going to have to take the international house approach with penetrations in beams and things. It's just
which adds a lot of cost. So look, it's about starting to think a bit differently, and your floor to floor heights is really important. Generally with these hotels, they're quite tight, about squeezing as many rooms on. The commercial offices tend to be a bit higher. So all of these need to be considered, and this is where the architectural views on it is really important. But I still strongly believe that there is a solution in there when you're combining all of them, and something that should be considered.
Yeah, for sure. And yeah, not to bang on about it, but the Brock Commons is a perfect example of that.
Yep. And look, it leads into discussion about services and coordination of services in your design, but also thinking about the constructability. And what you see here is an image of 55 South Bank, which needed to be fully encapsulated. And then you've got the Lend-Lease commercial office style, which is exposed soffit and services installed. So my point here, away from the service penetrations and all of that, it's a sequencing having to put the fire to plasterboard on first, then the services, in comparison to just putting the services on. And what that also links to is the need to provide temporary waterproofing to your deck above, and when you start this fit out. So there is a possibility of putting your services in with an exposed soffit underneath, and water can still travel through. Obviously you want it to be minimal, but with the plasterboard, you really need to stop a large percentage of the water, because the plasterboard really struggles to maintain the moisture of the water, and water can get trapped between the timber and the plasterboard. So what Nathan jumped to here was some images of different waterproofing methods, where we looked at waterproofing just the joints, but also running a more breathable wrap. That's a Proctor wrap, pre-installed on the CLT, which work better, however more costly. And we needed to do that just to ensure that we can continue our fit out and not get too many water damage or water issue management problems on the project.
Yeah, well, I think it's important to note that it's going to rain on site unless you've got a very small building. Chances are you're going to get some water, and it's more about the management, as Rob has mentioned. Like, timber can get wet. I guess for me as an engineer, the biggest challenge around that I see is the potential issue with axial shortening, because if you're increasing the moisture content, that's eventually, or it means that you're going to have a greater difference between what's installed, and then once you've got a constant sort of climate, once it's all locked up and in use, there's a greater differential between the moisture content during construction and in use. So that can lead to greater shrinkage and things like this, but it can be managed effectively and also just monitored during construction. Like with 55 South Bank, myself and others constantly monitored the moisture content of it, and it was able to be managed effectively with these sorts of approaches.
Okay, so talking about facade as well, this is important to any building, and it's the same with a hotel. So we just want to link this to the sequencing. So at 55 South Bank, we ran with a curtain wall facade. Really fantastic result. I think it's the champion component away from the mass timber on the project. But because we only had one crane, we had to supplement that with what we call a spider crane or a crawler crane, which is very small. And on the image on the left, what you can see is on the back corner, we're lifting up CLT to half of the structure, and we're installing facade on the other side, where we've got a small crane just manoeuvring around the active deck and dropping curtain wall panels over the edge. So it worked really efficiently. It's probably the most efficient component of the project, but it's something that needs to be really considered during the design, and how that's connected and how that works in with the timber component.
Yeah, I think it's important to tie this back to your site access and cranage as well. Like, it's been an interesting exercise to discuss the potential opportunities by having two cranes on a project like this compared to the obvious costs, and what that would mean for the sequencing and the speed of construction and things. So that's just an important point to consider.
Yeah, absolutely. This was another project. This is not a hotel, but it's student accommodation. So very similar style of structure, and the philosophy can be worked through as well. And what you see here is a job that the whole structure was put up, and then they used a prefabricated brick snap system and lifted it in. So the tower crane was not active because the structure was up, and they were dropping the CLT, the prefab panels in after the structure was installed, and that was connected directly to the CLT, be it to the slab or through the wall or into the wall, not knowing the details exactly. But you can see here too, you can see all the similarities to the previous US project that Nathan showed with the brick facade, and it's showing the different methodologies that can be looked at from a design perspective with a hotel in order to manage a facade component. This is another project. This is Avio in Sydney, which was built by Strongbuild and for Malfa. And they adopted a scaffold approach where they built the scaffold, chased up the timber structure, which then allowed the facade to be installed manually via the facade component. And it's pretty obvious why. You look at the facade, it's pretty complicated. And we wanted to put different examples of facade on there and just show that they can be adopted to a timber frame or mass timber structure, but the different methodologies that need to be considered and how they relate to cost and design to achieve that.
Yeah, I think I'll just add, from a design perspective with your facade, it's really important to understand the design criteria. Generally, you're going to have much more restrictive design criteria for deflections and things like that to limit deformation of brittle materials and that sort of thing. But it's also worth noting with things like the brick snap system, a prefabricated panel like that is much heavier. Obviously, you need to consider the design loads there, but also the eccentricity. So how that actually acts on your wall system, be it light timber frame or mass timber, and that in conjunction with out of plane loading like wind and things, that's just an important design consideration there.
Yeah. Hybrid, you can talk to this one, Nathan.
I'll have a quick chat. So this is, so with hybrid construction, as Rob mentioned earlier, it's very uncommon to ever have a real pure timber solution. And here you can see some of the steel cores at 55 South Bank. So the most important part here is the interface with the CLT structure, which for the left image is to the right. And you can see the connection detail down on the right-hand corner there. So what we did there to accommodate the axial shortening of the timber in comparison to the movement expected of the steel is to have vertical slots to allow vertical translation. And this was already working towards the end of the construction of the timber structure. So that's just one example. Rob, do you want to chat about maybe just...
Yeah. So what was really interesting on this project was that the steel core was selected for numerous reasons, and it couldn't be timber, but a lot of it was erected stick-wise on site. But with it being next to the mass timber, we saw the elements of prefabrication, and that just led to the steel becoming highly prefabricated on the job as well. And as you can see on the top right-hand corner and on the left, it's a stair that was pre-installed in a factory to the entire level of one of the core steel drop-ins, and we're able to lift that up in its entirety and drop it into place. So it just shows that when you're dealing with these hybrid structures, it's really good and it's really important to make sure they both have a high level of prefabrication.
Yeah, I'll just add on that. Credit to the steel guys on this job, because I worked closely with them to literally, drop the cages per 2 levels, as you can see here, by 2 millimeter increments sort of thing up the building. So it was very precise for steel. I think they looked at it and thought that's a bit of a joke, but we monitored that all the way up the building to actually work in with the theoretical axial shortening.
Yep. So this is another project. This is the Brunswick job where there was a fair bit of steel incorporated, and the message here, albeit not a hotel but an apartment, I can see a lot of requirements for steel in these types of structures, especially if we're not going with that possible honeycomb structure. But the example here is that the steel wasn't modelled. It was modelled in conjunction with the CLT, but we had two people modelling it from a supply perspective, and it created issues on site. So really, it's about being able to model any of the non-timber elements, be it concrete or steel, in conjunction in the same model, the same organisation, and then also having the installation incorporated. So we had a CLT installer as well as a steel installer, and there was coordination issues. So even CLT would turn up on site, installed, have to leave, then steel would have to come in, then leave, then timber, and then steel, and it was quite inefficient. So the message here is with these types of materials is really try to package it up from a design, modelling, and installation perspective.
Yeah, and it's all far too common for that sort of mismatch on site and that grey area, so to speak, where these elements interface, and the confusion around whose responsibility it is. Because no offence to any steel guys, I doubt many are tuning in, but I'm sure you'll probably take pride in this more than anything. You're definitely the roughest trade on site most of the time, and they'll pick up the nearest screw, and if that fits in the hole, that's going in there. And I've had to, on most projects, go through and do a lot of rectification works on jobs for that reason. And yeah, coordination is key. That's what we really want to highlight. So just to discuss axial shortening in a little bit more detail, I'm sure anyone that's tuned into any of my previous presentations has seen this slide or something similar. Won't go through it in too much detail, but I just want to highlight the importance of axial shortening for any timber design, particularly for timber elements that have grain or perpendicular to grain in the vertical load path. And that's even more paramount for light timber framing, because you're going to have far more elements that have components or parts of that structure in cassettes or timber frames, like your top and bottom plates and these sorts of things that are perpendicular to the grain. So you get a lot more shrinkage and strain and things, and joint closure in those elements. And also, if you do have, say, an extension of some nature where you have a transferred deck, understanding that interface and the stiffness across that deck is really crucial, because that's where you obviously are transferring the load from one load path or load system into another.
Yeah, and look, I just want to add to, there's a lot of discussion about this sort of stuff with a hotel building, because you're running with load-bearing walls in comparison to the columns, that if you design column on column, you don't really have to manage this as much. So with these hotel types of structures, be it mass timber or lightweight, you need to deal with this, but don't be scared of it. And a lot of people have gone down a path of these really fancy castellated connections and holes and pouring concrete into these holes to help transfer the load. It can be managed. Look, the higher you go, the more difficult it is. But we've got an example at 55 South Bank where we've gone 10 levels, and we've been able to manage it. We've been able to calculate it. We've been able to coordinate it with both concrete as well as steel throughout the building, which is quite unique for that type of building, but it definitely can be managed. So my point here is really about just getting the right people involved and not be scared of it, because it's not something that should deter you from looking at these solutions with a hotel style structure.
Yeah, certainly. And back to that sort of castellated or reinforced system, I get asked that all the time, actually, particularly on 55 South Bank. Why didn't you do that? And in my opinion, we were able to manage it with clever connection detailing rather than complex CNC, and it just, changes how you have to connect things, and there's a lot more installation challenges with that approach, in my opinion, and a lot more risk involved with that, rather than looking at it and dealing with it accordingly with the
and from my perspective as the builder, we would never have let you go down the castellation, because it's absolute pain and huge amount of money, really difficult to install. You're dropping another level of tolerance in there, and especially if you're getting some moisture in the timber and those castellations starting to swell, You got a 12-metre long by 3-metre high piece of CLT on the hook, and trying to thread all these needles just doesn't. It just, well, it can work, but I'm not a huge fan of it.
Yeah, totally agree.
So connections and fixings. From a buildability perspective, I felt that 55 South Bank really captured a lot of efficiencies in this space. And of all the jobs I've seen around the world, it's probably got the least visual connection. And what you see there is you can see the corridor as well as a zoom in on one of the connection details. And in the corridor, all the screws are stitch screwed through the CLT into the floor below. And on the right-hand side, you can see the screw heads. And we worked very closely with Vistek, did an exceptional job with this, that allowed us to remove a lot of what you traditionally see in these types of structures with the brackets, and to run these screw connections. Now, every job's different. Earthquake loadings, just general loading needs to be considered. But what Vistek did on this was really simple, worked really efficiently, even down to the point where every screw at that connection was the same screw. They just increased the centres as you went up the building and the load reduced. And that large bracket was a more intense bracket that was needed on certain shear walls on both ends. And they were strategically located to be where your acoustic wall needed to be. Now, we didn't want to spend too much time talking about acoustics. There's a slide at the end, but acoustics and fire is really important, because you've got to build your floor up for acoustics. You've got to have a ceiling for acoustics. You've got to fire at a plasterboard, and you're going to have a false wall in front of these walls for all your acoustics around all your hotel style design. And trying to coordinate these bracket designs into those finishes from an architectural and engineering perspective is really critical. And I've seen jobs around the country where brackets are left exposed, the floor covering only covers part of it. You can see it, and it's just, I just don't feel like it's the best outcome. So trying to reduce those screw connections and make them more efficient from a design, cost, but also installation side of things, because dealing with any subby who is dealing with one screw all the way up the building for this type of connection is much, much more efficient.
Yeah, you really want to make it as foolproof as possible, and it makes the site inspections much simpler as well, to go through and check that it's been done correctly. Yeah, like Rob mentioned, you have to really design for the loads, of course. With any timber, a larger quantity of smaller fixings is always best for ductility, but it's not always necessary. So just designing to your actual design loads is really crucial. I just want to touch on just in the left image, somewhat related to both sequencing and connection detailing. You can see that there's a bit more of a gap on the outside of the corridor panels. Now, this actually was done because I looked at this project, and just due to the changes in direction, it was really important to have a greater tolerance for this. And that was really appreciated by the installers. There was a bit of pushback initially, just due to the fact that, you know, most of the time CLT buildings are designed to 1 to 3 mil tolerance. And I was adamant, based on my experience, that we needed more in at least one location. And that does tie into your connection detailing. And I think it's an important thing to consider.
Yeah, and just before we jump off this slide, we were talking about services before we showed an image, but this does reflect it a little bit better. If you look down the corridor, you can see the doorways, and you probably would have noticed it with the panel we lifted up that you saw on the long shot had the holes pre-cut. One thing about these hotels and services and running with CLT, we were able to run with 3 hole types for the entire project. So all the services ran through the corridor and popped into every room with only 3 holes. And that was running your in and out for mechanical, where the fire dampers were fire tested, as well as a firebox, which allowed all the other services to penetrate through without having to do your centres. And it really simplified it and was able to be modelled, CNC cut, and brought to site. So a really huge benefit when you're looking at those types of components at CLT, but you need to balance that with the materials handling that we discussed before. Yeah, and look, this image was put on. This is more of the European approach. Now, look, I don't know the earthquake requirements at this location, but when CLT first came to Australia, the go-to was this type of bracket. And pre-installing the bracket and having them at certain centres was the go-to. And I really feel that the work we did at South Bank with Vistek really helped challenge that and just made you think a bit differently with the need of, are these connections needed? If they are, they're fantastic, they can work well, but are there ways of actually reducing it with more efficient ways of connecting?
Yeah, and it's just very slow on site to install those, particularly with nails, but slightly quicker with small screws, but still installers hate it and they hate you for it if you're designing it. Of course, you might have to on certain projects. I don't want to discuss too much, but on the right-hand side, you can see the rubber matting just for vibration and noise control or damping of the project, same with the brackets there. So that's more from an acoustic perspective, but just bear in mind what implications that has on your connection stiffness and stiffness of elements, because it will impact your shear stiffness of those joints.
Yeah, and just to add to, we'll probably touch on acoustics a bit later as well, but there's this perception in the market that you need all these rubber strips, and I'm not saying you don't, but most of 55 South Bank didn't have any, and we had a really strict acoustic requirement, and we did on-site testing, and we worked with some really good acoustic engineers, and it passed significantly well. So, looking at those rubbers, please, it's important to investigate because they are very expensive, and it's a very European approach that they've gone and say, look, it's needed, and it's something that should really be challenged during the design process. You can talk about this one, mate.
Yeah, so essentially just a slide of some connection examples, not all really related to a hotel necessarily. Obviously, that's a Lend-Lease International House up on the top left. I guess the main point here is, firstly, manufacturers of these brackets and connections can certainly assist you with the design. Your vertical and sort of lateral loading is pretty straightforward from an engineering perspective. I guess with connections, the biggest challenge generally comes around robustness and understanding how you're approaching robustness and whether or not these systems can accommodate the design requirements of that.
Yeah, and it's linking it to the hotel that if we are going down that post and beam, you need to consider these connections. What are they? How do they work? How are they fire rated? Are they tested? And then you've also got the floor cassette. So that's a tech beam floor cassette that was used at that Australand project. And there's connection requirements there as well. But most of these lightweight systems are cladded with fire-rated plasterboard on site. And then your connections are encapsulated within that fire-rated plasterboard. So it really can simplify.
Yeah, and when you have a panelised solution, your robustness is vastly simplified. It's quite economical to go down like a notional removal of elements path. You've got a lot of alternate load paths in those systems, and a lot of connections that are tying all the elements together. And
your service integration is pretty good there as well. If you just go back, Nath, you can see with that tech beam or a posi strut or something, you have space to run services within that construction depth, which, running a CLT panel, you don't. You need to run that underneath.
Yeah.
So yeah, look, fire and acoustics. And we could have a whole presentation on fire and acoustics. I'm sure Andrew's done quite a few of them. It's a space that's constantly evolving. Wood Solutions have some fantastic information, and it is something that seriously needs to be considered in hotels. A lot of hotels tend to have higher acoustic requirements depending on who you're dealing with and who the user will be. But in essence, the hotel compartment, especially when you're dealing with mass timber, it really helps manage that spread and running with really solid, tightly fitted walls either side and a floor. If a fire occurs in that compartment, it's very, very difficult for the transfer around. Where you're dealing with concrete, with lightweight walls and the tolerances between them and caulking and all those sort of things needs to be considered. But fire and acoustics are really important. You've got to understand it early and make sure you're detailing it to make sure that you're managing not only your vertical and horizontal, but your flanking. In a hotel, it's really, because you're dealing, especially with that honeycomb, noise can get into the floor, into the wall, and into the room in the corner. And we tested all of that at 55 South Bank and got well and truly above what the minimum requirements were for the client.
Yeah, I'll just add, I guess advice for fire would just be that from an architectural perspective, initially, don't be too ambitious with everything that you want to expose, and make sure that you get all parties involved, get in touch with your authorities, with your potential suppliers, make sure they have all the adequate testing and all of those things in order before you really, get things underway, because otherwise you're going to have a lot of headaches and some costly things arrive on the track.
And it's a good point, Nate, because when you talk architecturally, I honestly believe that your hotel is a really good opportunity to potentially expose CLT, and you can achieve acoustic and fire rating requirements if you've got a single wall, which would normally have direct fixed fire to plasterboard to it, and have your false wall on the other side. There's an opportunity there to run that as exposed. It needs to be fire engineered. You need to consider that. But there is an opportunity to do that. I'd probably lean towards that rather than the soffit. Soffit would mean that you'd need to build up above, but there's some pretty good composite timber concrete solutions coming out on the market now that allow a screed to be poured over the top. It improves the structural performance of it, allows it to span further, maybe can open up the opportunity for post and beam solutions. But with that concrete, you're also resolving some fire issues, as well as acoustics, and allowing you to expose the soffit. So it's definitely not saying you can't expose them. I think that's where the next step of the evolution of this design goes. It's, the first few jobs are fully encapsulated because it's easier to get it approved. And then we start peeling it back and starting to look for really efficient ways of exposing it. But my advice is to really engage with suppliers, acoustic consultants and fire consultants. So you're not saying, I'm caught up in exposing that wall. And it's like, look, guys, I'm sorry, but that's going to cost you a lot of money to expose that wall. How about this wall over here? Try to work that into the design early.
Yeah, and more importantly, I guess just the authorities, because at the end of the day, they can make or break a project. So.
Yeah.
All right, well, yeah, that's pretty much it. So thank you, everyone, for joining, and we'll try to get through as many questions as we can, I guess.
I'm assuming, Andrew, you not stepping in meant we covered off and everything, because normally I was waiting for you to jump in at some point.
Well, actually, in fact, I'm going to make some comments on a couple of things now. I thought you did such a good job that to break the flow wasn't the right thing. So we'll open up some questions. I'll start up with a couple of comments. And thank you, it was a brilliant presentation. And you note that it's the consideration and the working of the engineer and the architect and the construction person is where you lead to a successful job. So just a comment on the post and plate. There was a Wood Solutions webinar done on post and plate building systems. There's a rotoglass spider connection and a X-lam band beam, which was discussed about, which I did with Professor Forsyth back about 8 months ago. That's available on the Wood Solutions website to talk more about it. We're also going to do a project on that shortly, where we're going to virtually build a couple of these buildings, X-lam band beam and the spider connection, just to work out the construction issues. Because I think, if you can take away from today that the structural engineer isn't actually doing design, he's responding to the issues that are for construction and fabrication. So the engineer shouldn't be taking the lead. It should be designing what the best approach is to do the building. So post and plate, as I see, is the next frontier of these buildings, and we'll be doing more in that area. The other comment was Nathan talked about the axial shortening. I would just remind people that the Wood Solutions Guide number 50 has a technique in there for calculating that. If you're looking for a bit more detailed explanation, there's a report that my company and I myself wrote on bearing, and there's a calculation method to working out the actual deformation based on the joint group of the timber, which will give you effectively a perpendicular to grain estimate better. So it can be more of a serviceability check. And just a warning about numbers for European code versus Australian. The bearing numbers from Europe are measured or found in a different way compared to the Australian one. So if you got difference in numbers there, it's because how they measure them are different. We're going to hand it over to questions. I'm going to ask Nathan the first question. So how do you deal with this point I just made, is that you've got these buildings are successful because there's this collaboration occurring. So how as an engineer do you get that to happen?
Well, you pick up your phone, you're willing to talk to people, and you're willing to go to meetings. I think you got to want to to see these projects be as successful as possible. I mean, personally, I can't help but do that and, you know, give my opinion and 2 cents on things, but I also want to be involved in those conversations and understand how that's going to affect any of the engineering, or whether, you know, the engineering that I've done could be, you know, adversely affected by the construction methodology and those sorts of things. I think with, in terms of collaboration, it certainly starts with firstly the design, then understanding how it's going to be built, and then with your suppliers and the structuring process, and being involved with that, being prepared. I mean, obviously it comes with cost. You know, we're not here to do anything for free, but that's where the project team needs to understand that, yes, it comes with a cost, but there's a benefit during construction when you've actually collaborated and sorted all of that out. So,
yeah, and just to add too, I think the builder and the client has a lot to do with that. And it's about, I've been involved in projects where they've been designed to a really, really high level, and you need to, if you win the job from a builder's perspective, you need to then get started very quickly. So there's not a huge amount of opportunity to bring value to the table. Then there's other jobs that you actually get involved, where you get involved early and under an early contractor involvement, where you can start bringing in the suppliers and the consultants and start discussing these things and really bring efficiencies into the process before it gets too far down the track.
Yeah, and I know that, you know, in previous years, I don't hear about it as often these days, but that whole ECI approach, and I still don't think there's too many projects where that's really been done properly. Lots of the time it's actually still just that term for the contract, and that's after tender, where, like Rob's saying, the design's already done, and you're really, you know, your hands are tied in the approach that you can take and the, you know, the value management that you can add to it.
Yep.
Okay, some questions here for there's a question on the interesting talk, that wonderful, from Shandon. Just wondering if shrinkage or swelling due to RH change, relative humidity, influences the connector load, and how is this incorporated in the design? Sounds like an engineering question there, Nathan.
I'll pass that one on to you, Nathan.
I guess you're certainly right. You need to think about that. It's going to change on every different connection joint type, but you'll find that locally there's enough ductility generally in those connections to move. They're not. It's more of you know, sort of level to level that you have these challenges, rather than across individual joints, so to speak. Things like joint closure is going to happen anyway, but you're talking about, you know, typically in the order of 0.5 to 1 millimetre for those. I certainly haven't, you know, heard any noises on site, which tends to be a bit of a giveaway, or any, you know, heads pop off in these sorts of applications. Yeah, I think that timber's generally forgiving enough, and then the ductility of the steel bracketry and or fixings can accommodate those changes in a local sense.
Yeah, I'll just add that one, Nathan. The only time I've ever seen an issue is when someone put some strapping on the side of a building, and it's prior to the rest of the structure's gone up. So sometimes you'll be careful you don't fix it too early, because you got to remember that as the load goes on the building, it will go downwards, and sometimes that could cause an issue. So it could be the timing of those type of things. Yeah,
that ties back to I think, where is it? Jerry Howard's question about brick panel facade systems. So typically that sort of panelised or curtain wall facade approach, you'll have tolerance built into some form of transom. Most of them are top hung on the level above, really. So that's where you have to work with the facade supplier to add adequate tolerance to account for these sorts of axial shortening issues.
Okay, I think we have to call the questions to an end, because we're now hit 12 o'clock and need to finish off. So, Rob, any last final comments before we finish up for today?
Oh, look, I think hotels in this type of space is definitely probably the lowest hanging fruit. It's office construction in timber as well as hotels, and I really think there's opportunities there. It's the type of building that can be efficient, but you need to really work in early with everyone and get those right. And I think there's some good examples of that around the country, if not the world.
Nathan, quick comment.
Use direct load paths in any design that you do, and I don't think architects should be scared of that either. Like, I think architects should try to work around some just common sense structural approaches, particularly, you know, with timber design and everything. We're still relatively in our infancy with it. There's lots of robustness concerns and testing going on around this, and I think you're just going to mitigate lots of potential issues there by taking that approach. And it works beautifully, even if you look at, you know, all the Lend-Lease office projects. That's all direct load path, and they're some of the most beautiful timber applications in the world.
Thank you, Nathan. Thank you, Rob. Your brilliant presentation. I'll just take it out with the last of the talk. So we have remember that the webinar will be available, and those ones we mentioned before, particularly on the Axial Shortening and Poster Plate, are also available on the Wood Solution website. This is the third one in the series on timber building series. So we've now ticked off hotels. Next week will be on school buildings. And this one's an interesting one. New South Wales Schools Infrastructure has been doing exercise on DFMA approach to the school design. And we have the team involved in that, and they have also included a bit on the use of timber. So this team is going to be in next week's webinar, and we have quite a large crew there, which is from the client, the architect, the engineer, and also the cost study. So that'll be a very interesting talk there. But the next webinar is next Tuesday. So this is the By Tuesday webinar series. So we have this particular talk is on Macquarie University Clinic Education Building, and that was going to be presented by Luke Johnson and Mike King, and they are a very good team and I'm interested in talk. So I look forward to that talk. And remember, the formal CPD questions and certificate will be sent out to you post this presentation. And to help us in the form, there's a place where you can go to conduct a survey. We appreciate your thoughts and on this in formulating future talks. So in closing, I'd like to thank you and thank you again to the speakers, and we'll see you at the next Wood Solutions seminar. Thank you.